Today we will learn about the welding joint, its types and symbol. Welding joint is a permanent joint. We use various types of joints in welding procedure. Suppose one of them are lap joint, butt joint, T-joint, edge joint, corner joint, etc. First we will learn lap joint. This is your lap joint diagram. Lap joint means when two plates are overlap each other. See, this is plate number 1 and this is plate number 2. These two plates have overlapped each other. We can use welding on the upper side or lower side. When the strength of the joint is required more, then we will weld on both sides, upper side and as well as lower side also. See this diagram here. This is plate number 1, this is plate number 2, and welding is done on the upper side only. We can use welding on the both side also. And this is the symbol of welding joints. This is bevel group symbol. This plate is normal, but upper plate is used bevel edge. This is the symbol of bevel group. Here where we use the J groove, the lower plate is same, but the upper plate is used bevel group or J group. This is all about your lap joint. Next is butt joint. You see, in the butt joint there is two plates which are in same plane. It means two plates are side by side, and welding has been done in the middle. So this is another diagram of butt joint. Here this is plate number 1, this is plate number 2, and we have here used bevel edge. We can weld in this way also, in the upper side and lower side. When the metal plate are very low thickness, is less thickness, then we used square butt joint. The square butt joint, there is no need to bevel the edge, but when the thickness of the metal plate is more, then we use bevel group. It may be single side or it may be both side. Here we use the bevel edge in this plate number 1, and the plate number 2 there is no bevel edge, but in here we used the V group. It means the bevel edge has been done for both the material, and we weld in the middle of these two plates. And this is your symbol of bevel group. This is square group and this is V group. This is your butt joint. Next is corner joint. In the corner joint there is two plates are used which are right angle to each other. It means the inclination of these two plates is 90 degree. See this diagram where you used the welding in the lower portion. We can use welding on the both side, in the upper side and lower side. In both side we can use. When the material thickness is less, so then we use only single welding, and when the material is heavier or more thickness, we use welding on the both side. See the welding symbol here. One plate is no bevel and the second plate is bevel group. Here use the bevel group. This is the symbol. This single group, and this is J group. We use the bevel edge in this portion, and this is square group. There no need to bevel the edge, so weld symbol is parallel these two lines. This square group. Corner joint is very useful in the various field of manufacturing. Next is edge joint. In the edge joint, there are two plates are used are approximately parallel to each other. Here you see this is plate number 1 and this is plate number 2. These two edges are closed or parallel to each other. Here we use the two plates and the inclination between the two plates is very less. So here we use the welding on this above portion. Here I have used the welding on this joining of two metal plates. This is not very strong joint. This is used for only light material. And this is, you see the bevel group. Here one side it has been beveled and there is no bevel, so it is square group. Similarly, their U group is used. This is the symbol of U group, and this is all your about edge joint. Next is T joint. You see that two plates has been used for the T joint. The shape is as capital T. Here one plate is horizontal and one plate is vertical to each other. We can use welding on single side or both side. When the material strength is required more, then we use welding on the both side. When the material strength is less, then we use welding on the single side. See, this is your J group symbol, this is bevel group symbol, this is your T joint. The joint shape is as shape of T, capital letter T. Next is spot welding. In the spot welding, we use spot welding for the thin material or sheet metal. See, there's two plates has been used, and this is a lap joint, and this is the welding machine of spot welding. Here you see the foot switch or foot pedal, and this one and this one are the electrodes. The two metal plates is entered in between these electrodes, and we press the foot pedal for few seconds and then release it, and then spot welding is done as like this figure. This is the electrode, this one and this one is the electrode, and these two metal plates is joined by the spot welding. This is your electrodes, and after the joining you release the foot switch or foot pedal, and then this figure is done. Spot welding is very quick and easy process. No skilled labor is required for this, and there is time is required very less. And as arc welding, we do not use arc or filler metal or electrode or gas flame, anything. Just current supply is needed for this welding joint. Spot welding is very useful for automobile sector for joining of sheet metal or thin thickness of metal plate. Next is slot weld or plug weld. Slot weld or plug weld, both are same. For the slot weld, we used this type of elongated holes, and for the plug weld we used circular holes. First of all, we prepare one metal plate by using circular holes, and then prepare the edge preparation, that is grinding these holes, and then prepare the lap joint, and then use the TIG welding and fill this material of holes by filler metal. This is your plug weld, and when these holes is elongated this type of shape, then this is called slot weld. When you use circular hole, this is slot weld, and when use circular hole, this is plug weld. And see, this is your weld symbol. You first draw this chart of any dimension. First write name of the joint, then shape of the joint, and then symbol. First one is square butt weld. You write in pencil and block letters. Then for the shape of the joint, you draw this diagram of pictorial view of square butt weld. You can take any length of this joint. This is plate number 1 and this is plate number 2. Both these plates are in same plane, side by side. Then after placing these two plates, the welding has been done in the middle, and this is the symbol of square butt weld. Next is single half V weld. There is a bevel edge for the plate number 2. This is plate number 1. There is no bevel edge, and for the plate number 2 there is a bevel edge. And the same, these two plates are in same plane. After welding in the middle, these two plates are joined, and this is the symbol of single half V weld. Next is spot weld. Spot weld, you see plate number 1 and plate number 2 overlapping each other. Then the spot weld has been done in the middle. A circular spot has been done on the upper surface, and this is the symbol, just a circle of the spot weld. And this is seam weld. Spot weld and seam weld both are same. For the seam weld, the continuous welding has been done on the upper sheet, and this is the symbol of seam weld. Next is fillet weld. Fillet weld, you see this is plate number 1 and this is plate number 2, and welding on this side has been done, and this is the symbol, just a triangle, right angle triangle of fillet weld. Next is plug weld. See, on the upper face, the upper plate, there is a hole or a slot has been done, and then these two plates has been placed by overlapping each other. Then with the help of welding, you fill this slot by weld material, and this is the plug weld, and this is the symbol of plug weld. Now see the conventional representation of various metal. See, we have drawn the symbol of various metal. First one is aluminium, then cast iron, then copper or brass, then steel, then wood, then zinc or lead. First you draw this rectangular shape of any dimension. Then for the aluminium, you draw the hatch line of 45 degree and equal gap, 2 to 3 millimeter gap you maintain. This will for aluminium metal. Then the cast iron, the same 45 degree hatch lines are drawn, and the gap is more closer than the aluminium. You make more gap for the aluminium and the less gap for the cast iron. The angle of these hatch lines are 45 degree. Then copper, you use for same as aluminium, 45 degree and more gaps. Then in between gaps you draw this dash line. You maintain equal gap. It is for copper or brass. Then the steel, you see same 45 degree hatch pattern, and there is two lines are very close, then equal gap, and it is for steel metal. Then for the wood, you draw same rectangular shape and you draw this line with free hand, and this is for wood. And for the zinc, you draw 45 degree hatch line in both direction. These lines are 45 degree, and you draw again 45 degree line in opposite direction. So this is for zinc, lead or white metal. And all this rectangular shape of any dimension, but you use not pen, only pencil, only H pencil is used. This is conventional representation of various metal. And this is the table of machining component. First draw this diagram. First write title, then subject, then the conversation. You draw all this figure in the A4 page. First is straight knurling, then diamond knurling, then square on shaft, holes on circular pitch, bearing, external screw thread, internal screw thread, spine shaft, and then semi-electrical leaf spring. You know the leaf spring where it is used. It is used in a vehicle suspension. And see, this is the leaf spring, and this is the symbol of leaf spring. Spine shaft. This is the pictorial view of spine shaft. You draw this to circular hole, concentric circle, then dot this slot with the help of pencil and compass. Then the internal screw thread. Internal screw thread, you know, it is used in the nut, and for the external screw thread it is used for the bolt and stud. This is the drawing of a stud. This is the side view, and this is the front view of a stud. These two circles are concentric, and you can take any length or any diameter to draw this diagram. And this is the symbol of a bearing. There is various type of bearing. This is roller bearing, ball bearing, and this is the symbol of a normal bearing. Then the holes on the circular pitch. For the circular pitch, you see there is various holes, circular holes in around the circle, and you just draw one circle and mark the center line of the circle. Then the square on shaft. This is the square on the shaft, and this is the symbol. This is the circular part, but this is the circular shaft part, but this is the square part of the shaft. This is then the diamond knurling. Diamond knurling, you know, it is used in the various automobile component. When you use range or screw jack handle, then it may be slip. That's why we use diamond knurling. It is done by lathe machine, by the lathe tool, knurling tool we use. This is straight knurling. There is double cut for the diamond knurling, and for the single knurling, straight knurling, there is single cut. And this is the convention of straight knurling and diamond knurling. Now the conventional representation of spring. There is two types of spring is used. One is tension spring and other is compression spring. Tension spring is used in pen, toys, and medical equipment, and compression spring is used in automobile sector for the two-wheeler, four-wheeler in the suspension system. And this is the symbol of compression spring. You draw these straight lines with the help of ruler or scale, and these gaps are equal, and these 2 points are known as pitch, and this gap and all these gaps are equal. For the tension spring, you draw this arc, these two arc with same radius, and then join this line with the help of scale. This is the symbol of compression spring and tension spring. See, this is a diagram of various types of hole. First is simple hole, then threaded hole, then tapered hole, then counter bore holes, and then countersink hole. First, see the simple hole is a ordinary hole, but for the tapered hole, you see there is a simple hole, but then after the holes we cut the thread on this inner portion. Then the tapered hole, see tapered hole. For the tapered hole, the upper diameter and lower diameter is different. Upper diameter is bigger and lower diameter is small. Then the counter bore hole. For the counter bore hole, you see the upper diameter is greater and the lower diameter is less, but after a certain depth these two diameter has been separated. And next is counter sink hole. Counter sink hole and counter bore hole both are same, only the difference is the upper part. This is a angle, this is not vertical. For the counter bore this is vertical, this cut, and for the counter sink this is tapered, the upper portion. You draw in your copy the diagram of tapered hole and counter bore hole.